my name is Larry, and welcome to the Old Gazer channel. This is a channel where we talk about amateur astronomy, and specifically we try to provide some advice and practical information and maybe a little bit of inspiration and encouragement to those who are newcomers to the hobby or those who are perhaps inexperienced amateur astronomers. So that's what we're all about. That's why we're here, and I just want to thank everybody so much for dropping by. You can probably tell from what's arrayed on the table before me here that in this video we're going to be talking about eyepieces. Now, as is the case with all of my videos, this is going to be a pretty high level, simplified version of talking about eyepieces, and that's for the usual reasons. First of all, my assumption is, it continues to be, that most people who watch my videos are newcomers or inexperienced amateurs who may not know much about eyepieces. But the more prevailing reason is because, as I've stated many times, I'm a simple-minded guy. Simple is all I know. I just can't do more than simple. So we're going to keep it as simple, as non-technical as possible. But I must say that when you're talking about eyepieces, you have to get into a little bit of technical stuff just because of the nature of what they are. But we'll try to keep that to a minimum, okay? So that said, let's go ahead and get started. Now, I'm going to begin by astounding you with an amazing demonstration of logical deduction. And let's see if you will agree with that after you've heard of this. Here is an eye. Here is an eyepiece. Must have something to do with one another. This is a piece for the eye, right? This is an eye. There seems to be an opening in this. It looks like it might have some kind of a lens in that. Say, Eureka! I would say that this must be what you put your eye up to in order to look through your telescope to see an image of the object that you're trying to observe. Wow! Isn't that amazing? I told you this was going to be something. And I would like for you to know that there's many more where that came from. I apologize profusely for that very lame and probably misguided attempt to inject a little humor into these videos. I promise I won't do it again, but that promise is only good for this video. I can't promise anything for the future. Okay, so anyway, let's get serious now, shall we? Eyepieces. What are eyepieces? Well, eyepieces are, of course, extremely important. We couldn't be able to do much viewing through a telescope without them because, as I said in my little attempt at humor, they actually are the things that enable, they're little windows, if you will, that enable you to look through your telescope and observe the object that you're wanting to view in the sky. They go right here, of course, in the draw tube or the focuser or the focus tube, whatever you want to call this thing. They fit right in there, and of course you just look through there with your eye to observe the object that you're trying to view. So they really are that thing that you look through to see objects through your telescope. But of course we know they're more important than that as well, and that's what we want to discuss today. I want to look at some major metrics or attributes of eyepieces, and the goal of all of this is to just give you enough information so that you can make intelligent choices when it comes time to maybe shop for eyepieces or investigate eyepieces or whatever. Just want to give you enough information that you'll be able to know what you want and be able to make sure you're getting that when you go to get an eyepiece. Okay? That's what the goal of all of this is. Let's talk first of all about eyepieces just in sort of general terms, if you will. As you can see, they come in all shapes and sizes. In terms of the diameter of the barrel, they come in basically three sizes. There's one that's less than an inch, and these are pretty much relics of the past, but there's still a few of them around. This one and all of the eyepieces you see here have a 1 1/4 inch barrel. and they are designed to fit in telescopes that have a receptacle that will accommodate a 1¼ inch barrel. That's what most eyepieces are. You can get 2-inch eyepieces, which require a larger receptacle to fit in, and which also are way more and are significantly more expensive than 1¼ inch eyepieces, and they are primarily used in ultra wide angle eyepieces, and where you want a really big field of view, a premium view with a really big field of view. We'll talk about that a little bit more in a minute, but that's how most of them are 1¼ inch diameter eyepieces. There are several types of eyepieces. They're categorized into several types. For example, there are Kellner eyepieces, there are orthoscopic eyepieces, there are Plössl eyepieces, there are ultra-wide view eyepieces, and so forth and so on. I'm not going to get into a discussion of each of those individual types or categories of eyepieces, because this video is probably going to be long enough as it is without getting into all of that. If you want to know more about those different kinds of eyepieces, you can find out all that you want to know and then some about that by just simply looking for other resources, either on YouTube or other places around the internet. So I just wanted you to be aware that they are classified into various types like that, but that's not really what this video is all about, so we're going to kind of go around that here. Eyepieces come in a wide variety of sizes, of course, and a wide price range. This is a very inexpensive eyepiece that's costs about $20. This is a much better eyepiece in every respect, and I paid $150 for this, my most expensive eyepiece, and my favorite, by the way. Eyepieces, telescope eyepieces are a perfect example of the old adage that reminds us that you get what you pay for. The more you pay for an eyepiece, generally the better it's going to be in terms of its quality, in terms especially of the quality of the optical glass that you'll find inside the eyepiece barrel, and just the general build quality overall. For example, this very cheap $20 eyepiece it has one little piece of glass in there, and they've tried to make this look like metal, but this is actually just plastic painted to look like metal. So very cheap, very low quality. This one, as I've said, is very high quality, very strong, very solid build. It has a lot of optical elements in there, arranged in groups with very good anti-reflective coatings, and just as a good eyepiece. So you get what you pay for. You can pay over $1,000 for an eyepiece. Not that you have to do that, but if you have deep pockets and you want a really super high quality eyepiece, you can pay that much for an eyepiece. Now, you don't have to do that. I don't want to mislead anybody here by making you think that you've got to spend hundreds or $1,000 for an eyepiece. You can get decent eyepieces for much less than that. For example, this is a, pardon me, wrong one. This is a 25 millimeter Plössl eyepiece. You probably could get this for around $50 or so. This happened to come with a telescope that I bought, and it's a good eyepiece. I've enjoyed using this eyepiece and have no complaints with the view that I get through this eyepiece. So you can get a good, decent eyepieces that will let you enjoy looking through your telescope without breaking the bank. If you've got more money to spend, then fine, that's great, do that, because the better the eyepiece, the better your immersive experience will be when looking through your telescope. But you don't have to, break the bank to get eyepieces that are decent enough to use and get enjoyment from. So there is that. These three things over here are not eyepieces. These are Barlow lenses, and we're going to have a little segment about that near the end of the video. Very brief, very non-technical. These are not really eyepieces, they are devices that will increase the magnification of a given eyepiece. And we'll talk a little more about that a little bit later on. So that's just sort of the general overview of eyepieces. Again, they come in all varieties of quality bills. They come in all varieties of the quality of the glass that's inside the eyepiece. They come in different focal lengths that will allow different levels of magnification. They come with different fields of view from narrow to ultra wide, so that's just a kind of a general overview of eyepieces. So let's now get into a few more specifics, and we'll start with one of the most important metrics of an eyepiece, and that's the part that eyepieces play in magnifying the object that you're viewing through your telescope. A lot of beginners, a lot of people who don't know anything about telescopes kind of presume that the size of the telescope is the thing that determines the magnification that you're going to get when you're using that telescope. There seems to be a sort of an assumption that the bigger the aperture or the mirror or the lens in the telescope, the greater the magnification. That is actually incorrect and not true. The purpose of the mirror or the objective lens in a telescope, the aperture if you will, is not to provide magnification, but to gather light from the objects that you're looking at out there in the night sky. And the bigger the aperture, the more light can be gathered, the more things you're going to be able to see, and the better you're going to be able to see them, but that has nothing to do with magnification. There are two factors that figure into how much an object is going to be magnified when you view it through your telescope. One of those factors is the focal length of the telescope, and the other factor is the focal length of the eyepiece. Now, we talked in a previous video in some detail about the definition of focal length and that sort of thing. I'm not going to repeat that here. Hey, this is my way of enticing you to go back and watch the other videos about telescopes if you haven't already. But there's a discussion in there about focal length and so forth, and I'm not going to repeat that here. But there is a formula that can be used to determine the amount of magnification that you're going to get when you're using a specific eyepiece in a specific telescope. Let's review that formula briefly and go through a couple of examples here. The formula is this. Magnification is equal to the focal length of the telescope divided by the focal length of the eyepiece. Okay? Now, that tells you a couple of things right off the bat. You can look at that equation and realize that all other things remaining equal, that is, if you're using the same eyepiece in multiple telescopes, the greater the focal length of the telescope, the greater the magnification is going to be. Okay, so let's illustrate that with a couple of examples. Let's say that we want to put this 25 millimeter eyepiece in this telescope, which has a focal length of 1,000 millimeters. Now, if you go through the math, that means we're going to get a magnification of 40. When we use a 25 millimeter eyepiece in a 1,000 millimeter focal length telescope, magnification of 40. Now, we're going to use this exact same 25 millimeter eyepiece in this other telescope, which has a much shorter focal length, which is 350 millimeters. If you go through the math, you will discover that you're going to get a magnification of only 14x using this same eyepiece in a different telescope. So that's an illustration of how focal length impacts magnification. The greater the focal length, the greater the magnification for a given eyepiece. Now, you can also tell from that equation, you can infer very readily that the shorter the focal length of the eyepiece, the greater the magnification. Now, that's just the opposite from how the part that the focal length of the telescope plays in the equation. Here, the greater the focal length, the greater the magnification. With an eyepiece, the shorter the focal length, the greater the magnification. So that's just the way it works. Again, let's do an example here to kind of illustrate that. You put the 25 millimeter eyepiece in here in this 1,000 millimeter telescope, and you'll get a magnification of 40, as we've already shown. Let's now put a 10 millimeter eyepiece in here, And now the magnification, same telescope, just a different eyepiece. At 10 millimeters, we're going to get a magnification of 100x, 1,000 divided by 10. So that makes it apparent that you get a higher magnification if you use a shorter focal length within a given telescope. So that's how that works. So it's almost counterintuitive. You know, a short focal length eyepiece yields high magnification. A longer focal length telescope yields low magnification. And so that's how it works. You can tell from all of this that to get the maximum possible magnification, you would want a telescope with a long focal length and an eyepiece with a very short focal length. That combination will give you high magnification. If, on the other hand, you want low magnification, you would want a telescope with a short focal length and an eyepiece with a long focal length. And that's just how it works, and that's how magnification comes about. Now there are times when you will want high magnification, such as when perhaps you're viewing the planets or some of the detailed structure of the moon. You would want high magnification, and you would therefore want a high-powered eyepiece for that. There are other times when you would want low magnification, pardon me, and in that case you would want to use a low power, or pardon me, an eyepiece with a long focal length. For example, if you're looking at a deep sky object that covers a good angular distance in the night sky, and you would want a lower power to do that, and that therefore you would want an eyepiece with a longer focal length. So times you will want high power, times you will want low power, but there will also be times when you might like to have something in between, some magnification that's more appropriate for whatever object that you're attempting to observe. So when you buy an eyepiece, or when you buy eyepieces, you're going to need more than just one eyepiece in your collection. You're going to need a high-powered eyepiece, you're going to need a low-powered eyepiece, and you're going to need 2 or maybe 3 stops within those extremes to give you appropriate magnifications for those items that require that. So you probably should plan on having 4 or maybe 5 eyepieces minimum in your collection of eyepieces, which will give you enough flexibility to view things in the sky at an appropriate level of magnification. Okay? So there is that. One more thing that I'm going to say about magnification. I don't mean to extend this segment of the video too far, but this is relatively important, so let's discuss this for a minute. Telescopes have something called maximum effective magnification. If you look at specifications for a telescope, you will often see that included in the list of specifications, maximum effective magnification. Now what that means is there is a limit beyond which you don't want to try to magnify things when looking through a given telescope. There's a formula for calculating that, and that formula is you take the aperture of your telescope in inches and multiply it by 60. So this is a 5-inch telescope. It has a 5-inch primary mirror. 5 times 60, of course, is 300. So the maximum effective useful magnification for this telescope would be 300x. What happens if you exceed 300x? Well, you'll find that the image will start to become very dim very quickly after that. You'll find out that the image will get bigger, but there will be no additional detail, and there will just be some aspects of that image that won't be very pleasant to look at, and it's just not a good idea to exceed the maximum useful magnification of a telescope when you're viewing objects. Now, what that means, of course, is that you would not want to buy a telescope that provides magnification over 300x. You would not want to buy an eyepiece that provides a magnification of over 300x for this telescope, because that's going to exceed the maximum useful magnification of the telescope. And you can determine the shortest focal length eyepiece that you should buy by just plugging that 300x into the formula, and you will see that will determine for you what the shortest focal length eyepiece that you should buy for that telescope. You should always buy one that is no shorter, than that focal length. I hope that makes sense. You just don't need to buy any eyepieces that are going to exceed the maximum useful magnification of your telescope. All right. I hope that was semi-understandable anyway. Let's move on. Let's talk about another metric of eyepieces. Let's talk about field of view. Now, this is going to be very sweet and short, very high level, because we could spend an enormous amount of time talking about eyepiece field of view. Well, I just don't have time for that, and it would be inappropriate for beginners level videos. If you want to know a lot about the technical aspects of the field of view associated with eyepieces, there are numerous places to find that information out there on the internet or on YouTube, and you can learn all that you want to know and then some about what can be a very technical subject. But just in the most general possible terms, field of view refers to that portion of the sky that you're going to see when you look through the eyepiece in a telescope. You're going to see, you can either see a narrow field of view, which will show you the object you're looking at in a fairly small amount of space around that object, all the way up to ultra wide angle views, which will show you your object and a great deal of space surrounding it. I think eyepieces typically would run from about, let's say roughly a 40-degree field of view at the narrow end to 100 degrees or maybe even more at the high end. Now, you might guess, and you would be correct, that you get a much nicer, more immersive view if you're looking through a wide field of view. At least that seems to be the opinion of most people. When you look through a very wide field of view eyepiece, some have likened that to kind of looking through the porthole of a spaceship out into that vista of stars out there in space. It's that kind of an impression that you get. On the other hand, if you're trying to look through an eyepiece that has a very narrow field of view, some have likened that to trying to look through your telescope through a soda straw or through an opening that's even smaller than that. And that can be a sort of an uncomfortable and not very immersive experience unless you're deliberately looking for high magnification and a narrow field of view so that you can bring something as close to you as you can to see detail, such as if you're perhaps viewing a planet. But I can tell you from experience that wide field of view is nice. In fact, I prefer a wider field of view when it's appropriate to do that. Now, generally speaking, you're going to get narrower fields of view in less expensive, less complicated eyepieces, and that field of view can go up until you get up to 100 degrees. Of course, as you go up and up with field of view, the general trend is that the eyepieces are going to get more and more expensive as you go, and there will come a point when you might want to move from 1 1/4 inch eyepieces to 2 inch eyepieces, which we briefly alluded to earlier, in order to give you the absolute greatest true field of view. Of course, those eyepieces are going to cost a lot more than 1 1/4 inch eyepieces for obvious reasons. They're also going to be much heavier, which might upset the balance of your telescope if that's an issue. And you also have to make sure you've got a 2 inch receptacle that can receive those 2 inch eyepieces, or some kind of an adapter so that you can put them in here. So there will have to be some form of modification either to your draw tube or to your diagonal in order to accept those 2 inch eyepieces. So that's just kind of the way it is. This eyepiece has a 68 degree field of view. That's the greatest field of view that I have with any of my eyepieces, and I really enjoy that 68-degree field of view. Now you can go well beyond that, even in a 1¼ inch eyepiece. You can go to 82 or 100 or greater even, but that's very expensive to do that, and I've never had a lot of discretionary income to spend on my hobby. And I don't now. So there have been places where I've sort of had to draw the line and say this is good enough for me. And 68-degree field of view is fine for me. I enjoy that 68-degree field of view very much. Most of these other eyepieces have somewhere around a 50 to 60, a 40 to 60-degree field of view, which is fine for most viewing. But I really enjoy the 68-degree field of view, and I would encourage you to have, when you start to develop a collection of eyepieces, make sure you've got at least one in that collection that gives you a greater than, say, a 60-degree field of view, so that you can get a little bit more immersive experience when you look at things through your telescope. So that's all I'm going to say about field of view. Once again, research this on the internet, and you can find all you want to know about field of view and then some. I will warn you that a lot of this discussion you're going to see out there will become very technical very quickly. They'll start talking about field stops and the difference between apparent field of view and true field of view and how that's all calculated and so forth. That exceeds the goal, the ambition of my videos. So if you want to know more about that, just go out there and research it, and you can find anything you want to know. Okay, so much for field of view. Let's move on now to something called eye relief. Now, what in the world is eye relief? Well, eye relief refers to the distance from the lens of your eyepiece to the pupil of your eye at that point where you are first able to see the entire field of view within the eyepiece. Okay? Now, here's why that's important. You don't want to have a small eye relief, because that means you're going to have to jam your eye right down on top of the eyepiece, and your eyelashes might get in the way, or you might get something on that eyepiece. That's especially an issue if you have to wear your eyeglasses when you're viewing through your telescope. Now, fortunately, I don't have that issue. I can take my glasses off and focus without them. But many people have conditions that will not allow them to view without their eyeglasses in place. And you can understand why eye relief becomes critically important here, because you've got to have enough space between the top of the eyepiece and the pupil of your eye to fit your eyeglasses in. So it seems from the reading and research that I've done that the nominal threshold there is 15 millimeters. It's good to try to get eyepieces, especially if you wear eyeglasses, that has an eye relief of at least 15 millimeters or preferably more. Okay, and that's what that is, and that's why that's important. And that's all I think we need to say about that. The next thing that I want to talk about is something called exit pupil. Well, what in the world is exit pupil? Exit pupil refers to the size or the diameter of the image that comes out of an eyepiece when it strikes the pupil of your eye. Okay, that point, the diameter of the image when it strikes the pupil of your eye is called exit pupil. And here's why that's important. A typical human eye, a dilated human eye, has a pupil diameter of average of about 7 millimeters. It varies, of course, and as you get older, that gets less. But typically, on average, it's about 7 millimeters. Therefore, an image that is greater than 7 millimeters in size won't fit into the pupil of your eye. And so if you have a combination of telescope and eyepiece that results in an exit pupil of greater than 7 millimeters, then you've got a problem, because your eye won't be able to take in all of that image. Now, here's how you calculate exit pupil. And I hope that I'm not going to get too technical here, but exit pupil is equal to the focal length of whatever eyepiece you're using divided by the focal ratio of your telescope. Not focal length, but focal ratio. Now, we talked about that in some length in the videos I did on telescopes, but let me just briefly review here. The focal ratio of your telescope is equal to the focal length of the telescope divided by the aperture of the telescope. This telescope here has a focal length of 1,000 millimeters and an aperture of 127 millimeters. That works out to approximately f8. So this is an f8 telescope. The focal ratio of this telescope is f8. So if I'm going to be looking at something in this f8 telescope with a 25 millimeter eyepiece, then I'm going to divide 25 by 8, and I'm going to get about 3 rounded off. The exit pupil associated with using this eyepiece and this telescope is 3 millimeters, and that's good. That's less than 7 millimeters. That means it's going to certainly fit within the pupil of my eye, and I won't lose anything when I look at that image through the telescope. Now, at the other end of the spectrum, it's possible to have an exit pupil that's too small. Now, I'm not going to explain how you arrive at that figure because it's very technical, and I don't know enough about optics, and I certainly don't know enough about how the human eye works to be able to adequately explain that. And so in the interest of keeping in line with my simple-minded self, and to keep things simple for beginners here, I'm just going to tell you what I've read. The minimum exit pupil that you would want when you're looking at an object through a telescope is about 1/2 of a millimeter, 0.5 millimeters. So the idea here is, if you want to make sure that what you're looking properly fits within the pupil of your eye and it gives you a good view, you want to make sure that the exit pupil, the size of that image that's impacting your pupil, is somewhere between 1/2 millimeter and 7 millimeters. Okay, and you can calculate that, as we've already discussed, by dividing the focal length of the eyepiece by the focal ratio of your telescope. And you just need to make sure that that result falls somewhere between 1/2 millimeter and 7 millimeters. And I can tell you from experience, I know there are exceptions to this, but very few, it's very difficult to view something through a telescope with most any eyepiece and exceed the limits of the plus and minus limits of what the exit pupil needs to be. Very difficult to get an exit pupil greater than 7 millimeters. Very difficult to get an exit pupil less than 1/2 a millimeter. But you need to make sure before you buy a specific eyepiece for your telescope that it's not going to put you outside the bound of that important range of exit pupil. Okay, that's what that is. Now, I want to talk a little bit about these 3 things here. These are not eyepieces, they are Barlow lenses. And basically what they do is increase the magnification afforded by whatever eyepiece you're using. This is a 3x Barlow lens right here, which means that it will magnify, increase the magnification for a given eyepiece by 3 times. The Barlow lens fits in here, and then your eyepiece fits inside the Barlow lens like that. And now you will see whatever the magnification that will result from using this eyepiece by itself is going to be multiplied by a factor of 3. That's the way that works. Now, you can get Barlow lenses that increase magnification by 2 times, such as this one, 3 times, such as this one, 1.5 times, 4 times, 5 times. There are many, many increments of multiplication factors there that you can get. I almost never use Barlow lenses because I'm not a fan of real high magnification. Excuse me. If I'm looking at the planets and I want to get as much detail as possible, then yeah, I might use a Barlow lens to increase the magnification to give me a more detailed view. That's an instance of when I might do that. But you normally can't view planets at the highest magnification anyway, because you'd need really good seeing conditions to do that. And that's something, the seeing, the calmness of the atmosphere is usually not very cooperative. And so, you can't really normally view at extremely high magnification anyway. So Barlow lenses are good in some instances, and there are some specific applications when they work well. You can research that more. But I typically almost never use my Barlow lenses. Now, these two came with telescopes that I bought. I purchased this one separately. But I almost never use them, but they are there, they are available, and they can greatly increase magnification if you feel you have a need to do that. So those are Barlow lenses. Once again, if you want to know more about them and how they work and so forth, there are many sources on the internet and on other YouTube channels where you can find that information. Okay? A couple of other things here about eyepieces before we wrap this up. I almost never use these eyepieces, okay? And I'm going to explain why you might not need to have a big collection of eyepieces. These eyepieces, frankly, for one thing, are not very good eyepieces. They came with telescopes that I bought, and normally you do not get the highest quality eyepieces when you buy a telescope. You're lucky if you get some decent eyepieces. Most of the time they may be a little bit less than average quality. So these are not very good eyepieces. They served in the beginning when I was first looking through telescopes, but I almost never use them. These are the only three that I really ever use. This one is a good quality 25 millimeter Plössl eyepiece, which I enjoy looking through sometimes if I just want to do some quick viewing. This is my favorite eyepiece. This is a Baader Hyperion modular eyepiece. It's a 24 millimeter eyepiece that provides a 68-degree field of view. It has really good optics in it, really good coatings in it, very good solid build quality, and I just really enjoy the immersive experience of looking through this 68-degree eyepiece, and that's what I will use whenever I can, because that's my favorite eyepiece that provides the most enjoyable view of all of these. Now, let me tell you the reason why I don't have to use these small focal length eyepieces in order to get great magnification. This is a zoom eyepiece, and these are becoming a little more common over time. These zoom eyepieces work just like the zoom lens on a camera. By turning this ring, you can change the magnification without having to change eyepieces in your telescope. This particular one ranges from 8 millimeters up to 24 millimeters. And you can instantly change the magnification from 8 to 24 or anything in between just by turning this ring and focusing in or zooming back. Extremely handy, extremely convenient to use. It kind of obviates the need to take a whole bag of eyepieces out with you. And they do provide decent views, and they're getting better. Now, this one is a Celestron zoom eyepiece. I paid about $100 for it, and it works pretty well. I enjoy this eyepiece. I don't have any real complaints about it. You can get other more expensive ones. Baader, for example, makes an 8 to 24 millimeter zoom eyepiece that costs about 3 times what this one does. But for now, I'm satisfied with this. So with this combination of eyepieces, I really feel like I have all I need. I don't need these, and I don't need to buy any others. For the foreseeable future, I don't plan to buy any more eyepieces. That might change somewhere along the way, but right now, I feel very comfortable that these 3 eyepieces meet my needs as an amateur astronomer very well. And you may come to a small set of eyepieces that will do the same for you. Let me mention one more aspect of these two eyepieces. Some eyepieces, not all, by any means. In fact, these are probably still in a minority, but some eyepieces are threaded at the top. You remove the rubber eye cup, and you will find that they are threaded at the top. Now, why would that be? Well, these will accommodate a T-ring. You can screw a T-ring onto the top of these eyepieces and thereby connect your DSLR camera directly to the top of the eyepieces, which allows you to do eyepiece projection photography through these eyepieces. I like that very much. You know, you can always do prime focus photography where you just connect your DSLR directly to your telescope with no eyepieces involved and just use your telescope as a huge lens attached to your camera. But I kind of enjoy eyepiece projection photography because that gives me the option of using a level of magnification that I feel is appropriate to the object that I'm photographing. So I appreciate these eyepieces very much because they have, you know, that little extra added feature. And that's another reason why I enjoy those very much. Okay, final thoughts. Eyepieces are extremely important. They're one of the two major determinants of the level of magnification you're going to see when you look through a telescope. They're going to provide different fields of view for different applications. You'll want to make sure that to the extent that you can, that they've got high quality coated glass, optical glass inside, that they've got a good build quality. And you'll want to make sure that you have one that has at least 15 millimeters of eye relief or more, especially if you wear eyeglasses. You'll want to make sure that it's compatible with your telescope in such a way that you're not going to get an exit pupil that falls outside that range of 1/2 to 7 millimeters. And you're going to make sure that you've got, you know, a decent range of magnifications that might involve having several different eyepieces, or you might want to try out one of the zoom eyepieces, which can eliminate the need to have a big collection of eyepieces. So that's kind of my story of eyepieces. That's my story, and I'm sticking to it. Oversimplified, I'm sure. Maybe not quite, maybe it was as clear as mud at times as I went through this. I hope that I made at least some sense, and that you now will have an appreciation of eyepieces, at least to the extent that you will know what to look for when you get ready to purchase eyepieces or when you're evaluating eyepieces. So we'll call it quits for this video. I certainly hope that you have learned something of value here. That's the whole purpose of these videos. If you have learned something, enjoyed the video, if you like the channel, perhaps you wouldn't mind liking the video or subscribing to the channel. Now, let me explain something in regard to that. I am not soliciting likes and subscriptions in the hopes that I'm going to make money from these videos in some way. That is nothing close to the truth. The only reason that I would like to get, and by the way, if you don't like the video, please indicate that as well. I'm trying to use the likes and dislikes and the number of subscriptions as a form of feedback. You know, I'm trying to give something back to a hobby that's given so much to me over the years. And I appreciate all forms of feedback, which will let me know whether I am even remotely close to achieving the objective of helping beginners into this hobby. And, you know, to the degree that I get likes and dislikes, or the degree that I get subscriptions, is one indicator to me, along with things that I see in the comments, of whether or not I'm even remotely close to doing a good job of what I want to try to get done with these videos. So, not trying to make money by soliciting your likes and your subscriptions, just trying to use that as another form of feedback to maybe help me a little bit. And by the way, I appreciate any comments that you would like to make. Negative comments are appreciated. If there are things about these videos that you don't like, If there are things you would like to see me do differently, let me know and I will try to accommodate those as much as I can. I need your feedback to know if I'm anywhere close to doing a decent job in helping you along as you enter into and pass through the learning curve associated with this magnificent hobby. So that's what that's all about. Thank you so much for stopping in. I hope to see all of you again. And in closing, let me, as always, very sincerely wish you clear skies and good viewing.